Hi guys, Björn here from the Bavarian Builders, and I've got something here that you guys, or some of you guys, may be interested in. So everybody knows these MP3 player modules. I'm not going to name them, but they're cheap and cheerful, and they were fantastic in times when MP3 players were hard to come by for hobby purposes, and most of them were pretty big. These days, I think it's safe to say that nobody really likes them. There's 4 variants of this in terms of hardware, 4 different chips, maybe even more. I'm not entirely sure. Every chip variant has a number of firmware variants. You never know exactly which one you're going to get. On the client, on the Arduino side, you have several software libraries to talk to this thing. None of them support all the features that these things are theoretically capable of. None of these things support all the features that they're supposedly capable of. They're a nuisance to debug. So I thought we can do one better. So what you see here is what we call the Danube Fanfare player. Danube because of the river over there, fanfare because it makes a sound. So this thing consists of an ESP32, an Adafruit BFF that has an amplifier, an audio amplifier, and an SD card reader. And the whole thing is mounted on a prototype PCB, which is definitely not my proudest job. That makes this whole package pin compatible with the other MP3 player. And the software makes this 100% software compatible with the other MP3 player. So if we put it to work in my DO here, so here we have DO with the slot for the regular MP3 player. And if I take that out and supplant it with the exchange module, and then power the whole thing up, then what you're going to hear is first the player announcing that it's starting up.
Sound system ready.
This is the player itself, and the rest of what you're going to hear right now.
Self-test starting. Please stand clear. Power. Voltage too low.
Is coming from the Maker Wi-Fi using a standard software library that's supposed to talk to these guys, and now it's talking to that guy. So 100% pin compatible and software compatible replacement. Then why do it? What the hell does that buy us? Well, let me show you really quick by hooking the player up to its USB port. So what we have here is a serial terminal connected to the USB serial port in the player. And it understands a couple commands on the serial line. So we can look at what's happening in the file system. We see there's a couple of dot files here, there's a couple of directories, and there's a wave file here. So first of all, what we can do is we can check, is the SD card actually operational. In this guy here, you have to guess if it's outputting something. If it's outputting an MP3 or a wave file, then obviously everything is good. If it's not, one guess is, well, the SD card might be broken. But you never really know. Here you can actually check. Now, of course, what you can do is you can say play that wave file that we find in here. We can also say play 1.1, which plays the first file in the first folder. And here the naming comes into play. So the way that it's configured right now, it's ignoring everything that doesn't have a 1 or that doesn't have a numeric component in the beginning of the directory name and a numeric component in the beginning of the sound name. That's true for everything that comes over the protocol from the Arduino. Of course, on the command line, you can play anything. And it's configured. So there's this conspicuous file called config.ini here. And we look into that, then we can see that what we can do here is we can configure the bit per second rate. Standard is 9600, which is really kind of slow if you're calling the play commands from a busy high frequency control loop. With this one, you can go up to 2 megabits per second. We can switch Wi-Fi on and off. We can say file indexing starts with numeric and then orders alpha. We can say ignore dot files. That's going to be a boon for the Mac users. We can say ignore everything that doesn't start with numeric. Then there's a signal generator. Which you can use to debug your audio stream, right? There's if you have a square or a sine going in, then you can hook an oscilloscope, for example, to the end of your amplifier and figure out where the distortion is coming from. And of course, it allows you to have this thing make a sound regardless of any audio encoding and so on. Then we have the file player here where we can say play this stuff here on startup, set the volume, and yes, there is an effects section. Then we have the Wi-Fi, password, and SSID here. So we can configure all of this. And speaking of Wi-Fi, of course, we can play WAVs and MP3s, but we can also play an internet-connected radio station. And that's just the beginning. There's a ton more stuff to come. Can't wait to show you what's coming down the line. Okay, so putting it all together, what we have here is a complete pin and software compatible replacement for this MP3 player. Plays WAVs, plays MP3s, but adds a ton of other features that are mostly geared to easier debugging. You know, is my SD card working? Is my signal path working? Maybe I have a cold solder joint somewhere. This is the Danube Fanfare player. The PCB here that I've cobbled together is exceedingly simple. I will be offering these on my Etsy store for not a lot of money, but really it's just a diode and 4 wires. So if you want to do that on a piece of strip board, be my guest. Software is fully open source. I will put the link to the software repository into the description and also the link to the Etsy store. Now, I'm really interested in your comments and I'm really interested in your ideas. You know, now that we have this thing and it's able to play, oh, by the way, this is just for demo, right? Typically you would hook up a real amplifier on here. But now that we have this, what would you like to do with it in terms of your droid making sound? All right, thank you very much for listening and watching. I would love to hear your thoughts. Have a great evening. Cheers from the Bavarian Builders.